Our next section focuses on first derivatives and behavior of functions. So let's take a look at something called critical values. Critical values are the x or input values where relative or absolute maximums and minimums may occur. A couple of things here. First of all, relative max and mins can also be called local max and mins, and absolute max and mins are sometimes called global max and mins. We'll talk more about those in part 3. Another key piece is the fact that we say may. Once we find our critical values, we'll look to see if a minimum or maximum is actually at that value, but it's not guaranteed. So, where do we find these critical values? Well, let's take a look at this graph. It starts at A, goes up at B. Notice we have a local maximum here at B. The slope of the tangent line here at B is 0. So one place where we can find a critical value is where the derivative is 0. Another place where we can find a maximum or a minimum could be at an endpoint like D. Notice there's no derivative there. There's no tangent line at that point. So we could also find a critical value where the first derivative is undefined. So notice in the first example, that function f of x is a polynomial. So we're not going to have any jumps or sharp corners or anything because it's a nice, smooth, continuous graph. So the first derivative will be defined everywhere. That means we need to find our critical value by looking to see where the first derivative is 0. So let's find the first derivative, which is 15x squared plus 8x minus 12. And we need to know when this equals 0. We'll need to factor that trinomial, 5x plus 6 times 3x minus 2. And if you're struggling with the factoring, be sure you go back and watch those factoring videos as a review. And now we set each of these equal to 0. And when we solve, we get x equals a negative 6/5 and x equals a positive 2/3. These two values for x are our critical values. For the second one, we have y equals 2x minus 1 over 5 minus 3x. Well, remember, the critical values here could occur at two places, where the first derivative equals 0 or where the first derivative is undefined. Since we've got a fraction, and remember it is undefined, where there is 0 in the denominator. So let's first find the derivative. So using our quotient rule, low d high minus high d low over low squared, and then simplifying, we end up with the first derivative being 7 over the quantity 5 minus 3x squared. To find our critical value, we need to find where this value is 0 and also where this value is undefined. Let's recall that if we have 0 over a number, this equals the number 0. But if we have something over 0, this is when it's undefined. Since our numerator is 7, it will never equal 0. So we need to find out when that f minus 3x in the denominator equals 0. If we solve for x, we will get a positive 5/3. This is our critical value.